de la Cruz,
and I'm teacher Heidi Guado,
your teachers in Mathematics 7 for this week's lesson. In this video, you will learn about properties of operations on the set of integers and conversion of rational numbers.
So, listen carefully as we discuss the lessons for this week. The first lesson will be discussed by teacher Gaisel. I will see you in a while.
This lesson is a continuation of the concepts on the operations of integers. So, before we proceed to our next lesson, let's do some exercises. Perform the indicated operations. Apply the rules on the operations on integers. Number 1. 2 plus negative 15 plus 12 is equal to? The answer is negative 1, and you are correct. Now, number 2, 100 times negative 2. The answer is negative 200, and you are correct. Very good. Next, number 3, negative 4 minus negative 5. The answer is 1, and you are correct. Now, how did you solve each item in the activity? Did you use a shortcut in answering such? Can we solve it by using the rules in adding, subtracting, multiplying, and dividing integers? Yes, it can be answered using shortcut method. Based on the previous activity, you notice that there are many ways in solving the different operations. Let's consider these examples. For these examples, there are 2 solutions. In example number 1, 5 plus negative 23 plus 35. One way of solving this is by adding the integers from left to right. That is, we add 5 and negative 23. Then add the sum by 35. Another way of solving is that instead of adding integers from left to right, we add integers with the same sign. That is, 5 plus 35, and then the sum is added to negative 23. Either way, both solutions will yield the same answer, which is 17. Example number 2, 7 times 13 times 5 times 10. There are 2 solutions. One way of solving this is by multiplying 7 and 13, which is equal to 91, and multiplying 5 and 10, which is equal to 50. Then, get the product of 91 and 50, and the answer is 4,550. Another way of solving this is that instead of multiplying 7 and 13, multiply 7 and 5 since it seems easier. Then multiply 13 and 10, so we obtain 35 times 130, and the answer is 4,550. Either way, both solutions will yield the same answer, which is 4,550. In the previous activity, did you use method 1 or method 2? You notice that the order of the numbers was changed, but both solutions give the same results. This means that we can easily interchange the order of the numbers if it is easier and more practical for us to do so. This is one of the properties of operations on the set of integers. You will learn more properties of integers as you proceed in this lesson. From activity 1, we learned one of the properties of operations on the set of integers. Let us enumerate all with illustrative examples. Throughout the discussion, assume that the numbers represented by the letters A, B, and C are integers. Now, let us start our discussion on the different properties. Let's consider the first property, which is the closure property. And under closure property, that are added and multiplied remain as integers. The set of integers is closed under addition and multiplication. The closure property of addition for integers states that if a and b are integers, then a plus b is a unique integer. For example, 12 plus 14 is equal to 26. 12 and 14 are both integers, and their sum 26 is also an integer. The closure property of multiplication for integers states that if a and b are integers, then a times b is a unique integer. For example, multiplying two integers produces another integer. 15 times negative 3 is equal to negative 45. 15 and negative 3 are integers, and their product, negative 45, is also an integer. The second property is a commutative property, and it states that changing the order of numbers that are either being added or multiplied does not change the value. That is, a plus b is equal to b plus a, or a times b is equal to b times a. This property is applicable to both addition and multiplication. Let's take a look at the examples. Under commutative property of addition, let's have number 1. 2 plus 3 is equal to 3 plus 2. Next, number 2. Negative 16 plus negative 5 is equal to negative 5 plus negative 16. And for number 3, 100 plus 99 is equal to 99 plus 100. Notice that even if you change the order of the addends, we still get the same result. On the commutative property of multiplication, for example, number 1, 2 times 4 is equal to 4 times 2. Number 2, negative 4 times negative 15 is equal to negative 15 times negative 4. And number 3, 10 times 25 is equal to 25 times 10. Notice that even if you change the order of the factors, we will still get the same product. The third property is the associative property. In associative property, changing the grouping of numbers that are either being added or multiplied does not change its value. That is, the quantity of a plus b plus c is equal to a plus the quantity of b plus c. Or, the quantity of a times b times c is equal to a times the quantity of b times c. Let's take a look at these examples. For example, in associative property of addition, the quantity of 2 plus 3 plus 4 is equal to 2 plus the quantity of 3 plus 4. Now notice that in the left side of the equation, 2 and 3 are grouped, while in the right side of the equation, 3 and 4 are grouped. Anyhow, both have the same sum. Let's verify. The quantity of 2 plus 3 plus 4 is equal to 2 plus the quantity of 3 plus 4, which is equal to 5 plus 4 equals 2 plus 7, and we obtain 9 is equal to 9. Next, example of associative property of multiplication. The quantity of 4 times 3 times 5 is equal to 4 times the quantity of 3 times 5. Notice that in the left side of the equation, 4 and 3 are grouped, while in the right side of the equation, 3 and 5 are grouped. Anyhow, both have the same product. Let's check. On the left side, the quantity of 4 times 3 times 5 is equal to 4 times the quantity of 3 times 5. 12 times 5 is equal to 54 times 15. And we obtain 60 is equal to 60. The fourth property, which is the distributive property, states that when two numbers have been added or subtracted and then multiplied by a factor, the result will be the same when each number is multiplied with a factor and the products are then added or subtracted. That is, A times the quantity of B plus C is equal to A times B plus A times C. Or A times the quantity of B minus C is equal to A times B minus A times C. Here are some examples. For number 1, 2 times the quantity 3 plus 4 is equal to 2 times 3 plus 2 times 4. Notice that 2 is multiplied distributively to both addends and the obtained products were added. If we check, we have 2 times the quantity of 3 plus 4 is equal to 2 times 3 plus 2 times 4. 2 times 7 is equal to 6 plus 8. 14 is equal to 14. The fifth property is the identity property. It involves additive and multiplicative identity. In additive identity, the sum of any number and 0 is the given number. That is, A plus 0 is equal to A. Note that 0 is the additive identity. For examples, number 1, 54 plus 0 is equal to 54. Number 2, negative 60 plus 0 is equal to negative 60. And number 3, 399 plus 0 is equal to 399. In multiplicative identity, the product of any number and 1 is the given number. That is, A times 1 is equal to A. And take note that 1 is the multiplicative identity. For example, number 1, 32 times 1 is equal to 32. Number 2, negative 52 times 1 is equal to negative 52. And number 3, 69 times 1 is equal to 69. Lastly, we have inverse property. It involves additive and multiplicative inverse. In additive inverse, the sum of any number and its additive inverse is 0. The additive inverse of a positive number is the negative of that number. That is, A plus negative A is equal to 0. And the additive inverse of a negative number is the positive of that number. That is, negative A plus A is equal to 0. For example, 19 plus negative 19 is equal to 0. Next, negative 48 plus 48 is equal to 0. And for number 3, 402 plus negative 402 is equal to 0. For multiplicative inverse property, the product of any number and its multiplicative inverse or reciprocal is 1. The multiplicative inverse of the number A is 1 over A. That is, A times 1 over A is equal to 1. For example, number 1, 9 times 1 over 9 is equal to 1. Number 2, negative 52 times negative 1 over 52 is equal to 1. And for number 3, 3 over 8 times 8 over 3 is equal to 24 over 24 or 1. Again, the different properties of operations on the set of integers are closure property, commutative property, associative property, distributive property, identity property, numbers lesson. The next lesson will be discussed by Teacher Heidi.
Hello, this is Teacher Heidi and I will discuss the next lesson, which is on expressing rational numbers from fraction form to decimal form and vice versa. So, let's start. Study the rational numbers 4 over 9, 0.5, 3 over 7, 0.35, 9 over 13. Arrange them from least to greatest. Remember, a rational number is a number that can be expressed as the ratio of two integers. Now, what's your answer? If we arrange the rational numbers from least to greatest, the answer is 0.35, 3 over 7, 4 over 9, 0.5, 9 over 13. That is correct. How did you go about the problem? Yes, you realize that the only way the numbers can be compared is by making the numbers either all fractions or all decimals. So how do we express rational numbers from fractional form to decimal form and vice versa? The next part of the lesson will provide detailed information on how to express rational numbers from fraction form to decimal form and vice versa. Before we proceed to the steps in expressing rational numbers from fraction form to decimal form and vice versa, let us recall the definition of rational number. A rational number is any number that can be expressed as a ratio of two integers a over b, wherein b is not equal to 0. For example, 3 is an example of a rational number since 3 can be expressed as 3 over 1. How about 1.33? It is a rational number because it can be expressed as 1 and 1/3, which is equal to 4/3. Note that every rational number can be represented by either a terminating decimal or a repeating decimal. A terminating decimal is usually defined as a decimal number that contains a finite number of digits after the decimal point. Examples are 0.25, 3.256, 0.5. On the other hand, a repeating decimal is a decimal number that continues infinitely with repeated pattern. Examples: number 1, 23.562, 562, 562, and so on. The repeated pattern is 562. So, we can simply write the decimal as 23.562 bar. The bar indicates that the digits under it are repeated. Now, let us express the rational numbers from fraction form to decimal form and vice versa. There are some steps that you may follow. To convert a fraction to a decimal, simply divide the numerator by the denominator. Consider the following examples. Letter A, let us convert 1/4 into decimal. So, divide the numerator 1 by the denominator 4, that is 0.25. Therefore, 1/4 is equal to 0.25. For letter B, let us convert 6 and 4/5 into decimal. For mixed numbers, just set aside the whole number and work on its fraction part. So, dividing the numerator 4 by the denominator 5, then the answer is 0.8. This means that 4/5 is equal to 0.8, thus 6 and 4/5 is equal to 6.8. To convert decimals to fractions, Consider these examples. Solve for the equivalent fraction of the given decimals. For letter A, 0.25. Since there are two decimal places, so we can express it as 25 over 100, or in lowest term, it is 1 over 4.
For letter B, which is 0.135, since there are three decimal places, hence 3 zeros. So, we can express it as 135 over 1000, or in lowest term, it is 27 over 200.
For letter C, 6.45. Since there are two decimal places, hence 2 zeros. So we can express it as 645 over 100. When converted to mixed fraction, then it is 6 and 45 over 100, or in lowest term, it is 6 and 9 over 20. It can be noted that the previous examples are all terminating decimals. So, how can you express repeating decimals into fractions? For number 1, convert 0.77 and so on into a fraction. Step 1. Let x be the given decimal number. X is equal to 0.77 and so on. That will be equation 1. Step 2. Identify the repeated pattern. In the given decimal, the repeated pattern is only one digit, which is 7. Step 3. Since there is only one repeated digit, we multiply x is equal to 0.77 and so on by 10. Hence, 10x is equal to 7.77 so on. This will be our second equation. Step 4. Subtract the two formed equations. So that will be equation 2 minus equation 1. That is 10x is equal to 7.77 minus x is equal to 0.77. So the answer will be 9x is equal to 7.0. Step 5. Solve for x, then simplify your answer. So 9x is equal to 7. To get rid of 9, we divide both sides of the equation by 9. So that will be x is equal to 7 over 9. So therefore, 0.77 is equal to 7 over 9. So let us summarize that we have just learned. For number 1, converting fractions to decimals. For number 2, converting terminating decimals to fractions. And lastly, number 3, converting terminating decimals to fractions.
So, that's our lesson for this week.
We hope that you learned a lot.
Once again, I'm teacher Geisa de la Cruz.
And I'm teacher Heidi Bualo. Always remember, stay at home and always wash your hands, wear your mask too, and always observe social distancing.
And don't forget to like, share, and subscribe to our YouTube channel, DepEd Lawag City, and to our Facebook page, Oplan Balik Eskwela, DepEd Lawag City, School Namin All In. Goodbye and have a good day.